Okay, let's start. Good afternoon. Welcome, everybody. Today we will discuss cloud-native enterprise transformation the hard way. We will be talking about our observation and typical mistakes or misunderstandings very often in big organizations looking how to transform themselves into cloud-native innate organization. Okay, so we'll start with a short introduction about ourselves, who we are. Then we will discuss the cloud-native, how it differs from cloud-enabled, and what actually it is. Then we'll share some traps, shortcuts, give you some advices what to avoid, what to look at. So let's introduce ourselves. First, Marcin, please.
Okay, thank you, Artur. My name is Marcin Karkocha. I'm active open source contributor, or better to say, I try. I see significant value in open source movement. I'm talking about me as startup man. You can think what does it mean. I'm thinking about me as a project in context of planning, upgrading, selling, deadlines, that things. I have more than 7 years expertise in Python programming, from pure developer through architect to technical leader. After Python, I start working with cloud technologies, from private to public later on. I especially don't say here that it's about cloud native, because not of this project, all of this project goes this way. Some companies are satisfied by just migration to cloud. I'm working with these subjects mostly in telco and banking domain. And with same kind of clients, I work at Mindbox, where I'm cloud native architect. I'm building with clients something that I named system layer. We will talk about it later, but to shortly introduce it is about creating kind of abstraction that made migration and creation of new applications to be easier in cloud. And that's shortly all. Thanks, Artur.
All right, so a few words about myself. I'm a product guy involved in development of many products over the past few years, always looking how to utilize lean approach and automation in the product development. I spent a few years in Silicon Valley, also working on some new products in context of the cloud environment as a destination environment to deploy those products. And obviously then the cloud native approach to the software development, to the application and new functionality development becomes more and more important and well-defined for those products, for new functionality we're developing along the way. All right, so now we are utilizing those experiences in our daily work with our customers, and our customers are those businesses which are looking how to become faster and more agile in context of new functionality, new products, new business ideas they are developing on production for their customers with software. And for software development and new products defined in software development, the speed and agility is critical. And it is the biggest challenge for well-established big enterprises, how to transfer themselves into those modern, agile, flexible organizations with this type of infrastructure and processes built for the software delivery pipelines. Okay, next slide. All right, so in the typical engagement with our customers, we're helping with understanding or defining the strategy for the cloud native and related technologies and architectures, which are very often utilized or usually utilized in context of the cloud native approach. So on one hand, understanding how properly utilize containers, what are traps to avoid, how to utilize them in context of microservices architectures and in environments we're building together for this type of workloads. As we are experts in Kubernetes and we love Kubernetes, we are working on those environments using the infrastructure as a code approach, building programming and pipelines for organizations and teams. And usually there is always a challenge with the continuous delivery pipelines, which requires some updates and modernization, which leads to the enablement of the DevOps approach, which is more on the cultural and part of the organization. When you have all those building blocks in place, your teams, your people can truly act in this DevOps way and cooperate on new business functionality. And obviously, because those are enterprises, there is always discussion about the existing application and workloads, how to start, how to migrate, how to integrate legacy with a new type of application. So there's a big part of the I'm sorry, this is a slide too far. Just one more. Yeah, so in context of this type of engagements, we are working and utilizing our cloud native accelerator framework and starting with the discovery, various activities during the discovery phase, either helping to understand some core principles and helping to pick the right software stack. It very much depends on the maturity of the organization when they are on the cloud native journey. Then we're working on design of new environments, pipelines, and processes for applications, delivery processes and environments, and helping and working together on implementation of the environments and pipelines, and helping or enabling customer teams to operate those environments, processes, continuous delivery pipelines. And we stay with them very often as a trusted advisor along the way and later on. Okay, so now let's talk about the cloud native. Marcin, could you share your view, your perspective?
Yeah, sure. Okay, then let's start. When we are talking about the road to cloud native, it's good to look what's on this road. It isn't short, and even we can think that these points can look easy. We can think also that implementation that sounds straightforward. It's not true. When we look at it closer, we can see that 40 points were most dangerous. For me, the most critical point of this list is, of course, understanding what cloud native is. The popularity of this subject make that it's easier to find different definitions. However, only proper understanding of this subject give us the right foundations. From a technical point of view, we can think that cloud native is merely a set of modern tools and architecture patterns. About this, I want to talk later. Even from my perspective, it's not enough to think that way. It's a little bit more. Next step, when we know what it's about, is answering the questions that we want to do it. Even we can think that this answer should be straightforward when we listen to this presentation. Even maybe we want this easy answer. Reality and our character can block us to go this way. Once we discover that this is the right path, hardest questions arrived. And this question is how to start. I have chance to work in team that purpose is to answer this question. Of course, we can start without thinking, but also we can build massive big data team that in 2 years will answer this question. For me, important is to start anyhow. In this place, usually we land in the next point. We chose applications that are simple in migration. Maybe we found how to do it. Maybe changes are small. We made some kind of first success because few services works based on this new approach. In this position, we can find large number of organizations that start this adventure. In this point, this is point when we can stick fast. Application that we migrate works, of course. Another scare us or our managers don't see benefits in this migration. Most often, this situation is dictated that more work mean higher costs. We're in situation of suspension. From one side, we have good working platform. From another side, we don't use it properly or utilize it full potential, just because daily tasks are more important. In the meantime, or more intentionally, people start asking how it works, how you're doing that. You just code in YAML and everything works. These symptoms are right. It means that someone is thinking about how to start and collecting knowledge about how. When we make it company priority, we can enforce this process by organization of some workshops, combining people to work together. Essential role in this process falls on shoulders of project leaders. They should make that their teams are interesting in this subject. While we destroy this barrier of education, next step, also hard, was to obligate teams to build new systems the right way. I do it specially and put this point after knowledge because without good basements here, pressure on new Delphi varies can hurt our new ideology. I'll do. We achieve this point, rest should be much simpler. This way, most of organization achieve a magic point of 60-70%. It's a place where many companies stop and they get stuck. You can think why. At this moment, we have just, or maybe it's an evil word, still so much. Maybe will be more accurate. Old and scary systems we don't want to touch. I have to work in team as refactoring specialist. We have monolithic application with more than 100,000 lines of code, where many comments suggest don't touch it, it magically works. Most important is to go into it. Nothing gives us more power than first step in the right direction. Also, cleaning our solutions should speed up us. In mentioned previously system, I removed close to 40,000 lines of code without changing the logic of application, and just some shortcuts, modern idioms, choosing better tools or obtaining better core structure. After that, we can do the exact work. And here we achieve next point, when we can split our big, scary problems into smaller chunks that are much more accessible for us. When we look closer to it, we can see that our system have some kind of logical structure that we can directly break into manageable parts. These parts can treat as separated. We can replace it, rewrite, or use as base for new smaller services. If we don't know how to split whole systems into small parts, we can start with one most striking. One more time, I want to say that most important is to start. After this, we can fix our new, beautiful, tiny problems. And when we accomplish our trip, maturate with what we have done, from excitation, we move into daily maintenance. In our head, we can find some kind of understanding. We recognize that what we have is not that beautiful like sounds in the beginning, and it doesn't fully fit our imagination about it. I will say, don't be terrified at this moment. It's necessary to go here and accept that our system is never perfect. In a broader context, we can think about rebuilding from beginning, and we will achieve some kind of Zen. Of course, I'm joking. We are right in part of continuous improvement, then understanding that nothing is perfect. I keep repeating that where you're happy about everything, it's time to change work or something, because this is most dangerous moment in your life. As you have seen, it's a very long journey, and it includes many distinct subjects that we can use for sure to build many other presentations like this. And because of that, today I want to concentrate on one most important subject of this road, including its traps. It's actually what we start with, then understanding what cloud native is. Then let's look closer what we will talk about today. In agenda, we have some elements, or maybe more precise pillars of cloud native approach. I would also like to talk about tools that are important from technical point of view, but also about traps related with trying to choose right tools. I want to tell here about cloud enabled, and here I want to leave you with a little understatement to write this idea in time of presentation. On the end, I would like also to say a few words about what next after this understanding. Okay, then on start, I want to raise an essential question: what cloud native is. Actually, we can find multiple definitions, and unfortunately, it's hard to recognize one that will fit everything that it really is. We can see very complicated ones, like on Cloud Native Computing Foundation website. And we can also see many very technical, related directly with tools and move us directly to CNCF landscape, that part we seen in background. And in this point, understanding start being even harder, because like you've seen, number of tools is hilarious, and some of it do same job. Then maybe this understanding is wrong. I want to examine it for a moment together with you. To make it simple, let's start and look from where this comes. All the more, this is crucial point to everything what happened in modern IT. Traveling in time to beginning of commercial usage of software solutions, we can see huge companies, maybe giant will be more accurate. They have enough money to buy mainframes and use it. Over time, of course, this system evolved to enterprise systems on regular servers. But one factor is still right. This group is solutions for huge companies like international banks, chemical industry, and others that scale. Fixing problems in this model is pretty easy, as these types of companies get much money, then they hire more specialists and everything works. Actually, next step was proposed by companies like Google, Amazon, or Netflix. They are also huge, but with one difference, and this is key, that software is center of their business. What it means? It means that to optimize business, they need to optimize software delivery. This story gives us modern approaches like microservices, virtualizations, and automatic orchestration. Even that, still for them, fixing problem by scaling number of people in IT is pretty easy. And also, this is one change is justified as software is their business. Actually, word changes when microservices arrive to small organizations, and number of applications they must care about grows from 3, 4 to hundreds. Microservices are, of course, right solution for them because they can solve multiple problems like scaling, testing new approaches, reacting on growing number of users. However, and here is main difference, scaling number of people for a company that have, for example, millions of clients and just 20 technical people on board isn't solution anymore to fix software problems. And because of that, we've seen in this moment growing number of projects related to automation, some kind of standardization. Also, these approaches are built in open source manner. From my perspective, this is root of cloud native ideology, which is a continuation of it, and that gave both small and giant companies same flexibility and same possibilities. Okay, in this moment, I want to make our definition of cloud native. This one will try to short all available and touch every important subject in this matter. I don't want here to read it to you. Even I want to tell you what are essential aspects of it we need to understand. The first point is strategy. We can think what it's about. It's about design patterns, business strategy, or maybe methodology like Agile or DevOps. I would like to say that about everything and a little bit more. I want to say later in this presentation. Next segment is about building your system. This your is very important, as I said, introducing myself. This is what I do every day. This subject also I want to describe today better. Next element is application system. What does it mean? From my perspective is bird's eye view on the whole of our software system. It's not about just particular elements of this system like client service, internal tools on partner services, but it's more about architectural of whole of these components and about building standardization between these components that can apply same approach to each of these. This subject will be also subject of today's presentation. Then go to next and last but not least, and you can think that most critical part is cloud. Understanding what it is. For me, and this is a little bit wrong, most people think about it in context of AWS or Azure. My adventures start with private cloud as OpenStack contributor, and introducing it, I have seen significant change in mind of people that recognize that something like a private cloud exists. This is very important, I think, and it opens some doors in our heads. All of these parts give us possibility to build better systems, and let's then look what are metrics that can tell us when the system is better. We can consider here three main indicators that give cloud native advantage over old approaches. Speed, we can think about it here in context of delivering new services, deliveries generally, and tests of new ideas like A/B testing that can give us grow in our innovation and competitiveness. In place of traditional modes, we can get in cloud native all of these things I talked before, including not just new features, but also bug fixing just in hours. Next one is scale. As the business grows, we can continuously serve growing number of users, services, or devices. We can also make some kind of balance between performance and costs. Last one is margin or profitability. As capacity is available by hand, we can decide when we need less or more power. In the infrastructure as a service world, we can pay for resources we need only. And then spending goes from CapEx, then situation when resources are waiting for a request, to OpEx, resources are available on demand. Additionally, servers and resources for cloud native applications are much better utilized. Then it's also some win for us. When we know what are these metrics, it's an excellent place to tell about technical challenges we must consider before these measurements can give us some information in return. Then what are these technical components that can manage us to actual measurements when we apply it? They also are, for me, some kind of technical metrics of adoption. Of course, as creators of these systems, we know which parts are based on new approach and in which areas it doesn't work. With premeditation, I start here from cloud. As I said previously, most people don't know that they have some kind of cloud environment. In large companies, mostly is based on VMware solutions. Maybe automation is not too good, but still is some kind of cloud. So with just a few buttons or in more modern services, few lines of code, we can reserve new compute power or other resources. This understanding mostly comes slowly, and many companies think that going to cloud mean going to public cloud. It, of course, implied good result of cloud providers. However, as companies that trust about security, we feel some kind of internal fear about this area. We will be served there. I will tell you that I'm working in pilot program of migration banking company into public cloud, and then can say that this is 100% possible. But, and this is important, you must consider providers that care about your security and legal aspects like GDPR in Europe. You must think about continuous upgrading our and external service software. And with all of these factors, you can work in this area. Of course, considering that you are already find your cloud here, maybe it will be a good idea to start from it. I have chance to start this process in few large institutions, introducing OpenStack. It gives companies and people there feeling of having their cloud, even just UI and a few small things from their perspective was changed. This awareness was essential for them. It also fixed a problem with hardware that these companies bought 2 years ago and spent on it $15 million, and that node can be wasted. Of course, I know organizations that do that drastic step, but I think this is not needed, and we can use it already. Also, a public cloud can go to us with help when there will be need. We can find their help in hybrid cloud approaches, connecting our cloud with the public. Thanks to cloud native, it should be effortless. It also passes into margin measure from our success metrics, as we can extend our resources capacity available in our private data center by this available from public providers. It of course is connected with same problems or considerations like in model where we migrate all of our workloads to public cloud. But in the end, it gives us multiple benefits. Second point of my list is usage of tested patterns. As we know, number of it is pretty huge. Then today I want to tell you just about one that is my favorite, and this is CQRS, is stay from content query request separation. This complex pattern located on a system level. It describes the architecture of complete applications, then not code or services in our microservice-based world. The main advantage of it is separation between reading and writing operations. It builds kind of grouping for that and put operations between. It's also unusual in context of engaging other patterns and using the right tools that we saw earlier in landscape. As we have seen here, we have Istio, for example, that can do kind of the role of AP gateway, but also give us possibility to make A/B testing or request tracing in our system. We have here growing in popularity serverless functions. Some people say that is next approach after cloud native, but for me, this is just another kind of thinking about running workloads. We have here also currently mostly used in academic discussions unikernel, but my prediction is that in just few years, we should start using it like serverless today. We also have microservices, but this is nothing new. From the second side, we can find a group of tools related with data aggregation and operations, naming it properly ETL. We can find here Spark, Argo, excellent tool to automate processes. For example, it can react on files data, aggregate it, and send to Spark. We have here also Knative, known from serverless world, but it also can play as a builder for personalized our clients' images that can work faster because of that. Under whole of this stack, we can see technologies like Rook, Calico, that I will talk a little bit later. Using patterns and proper tools is very important in this world. It indicates better code quality, modularity, and in the end, give us better performance, which in our measurement is speed factor. When we are talking about the whole bulk of technologies and pattern we've seen previously. We can say, and this is very true, that maintaining all of this stack is impossible or too expensive manually. Here we come into the concept of automation and codification of everything. I'm evangelist of this ideology to make everything as a code. Of course, I'm talking here about both infrastructure that is currently popular trend in IT, but also about some not popular things like business processes, quality procedures, and configuration of our system. Today, we can also automate security compliance rules and, for example, things like people work and then some kind of procedures, how projects should go, using, for example, tools like GitHub Actions. I don't want to tell here about obviousness like building or testing our application, that are pretty old concept, and I'm pretty sure that most of you have it already, based on Jenkins pipeline or other similar tools. When we talk about codification, I want to mark here essential aspect of that, and namely, this is creation of code is not equal creation of files. I want to say here about significant difference between static and dynamic approaches to make these things. As an example, we have on one side Terraform, that is very popular tool, but from my perspective is also very static. On another side, we have, for example, Rising Pulumi, that do pretty same job, but using real dynamic programming languages. My recommendation is to use this second approach, even it can be just coding in YAML. Some people like to hate this idea. In the end, often this YAML is analyzed like in compiler and give us powerful tools like Ansible. It can give us also possibility to build easier code using conditionals. Built on this idea, tools was more abstract. For example, rather than defining elastic IP in AWS, we can just define IP, and using conditionals and variables, we can say in which provider this IP should be created, when it should be assigned into machine, and this should be static or elastic IP. All of these things can be just few words in our code. When in static approach, it's possible in multiple files. Of course, this is a vast subject, like the river we can see on the image. Then think what more can be codified. Here I want to introduce last but not least pillar, and most essential for me. Word abstraction was said and shall be multiple time in context, in multiple contexts, and this word is our last but essential point of this list. Both Kubernetes, like other tools built in cloud native approach, and this is one of main visible characteristic. They give us possibility to separate us from what underneath. This idea is also not new. Public cloud providers are first with this idea. Cloud native, on the other hand, move us here to the next level, as same abstraction can be used in different environment from different providers. For example, in Kubernetes, we receive operators and CRDs, custom resource definitions, built on these tools like Argo, Istio, Rook, or Knative, makes for us a layer that I named Company Framework. This framework gives us possibility to work on higher level and forget about details. Then using one tailored methodology, we can define different elements to build our applications. And often it means that in one YAML file, we can solve networking, storage, power, application build, and configuration problems. It gives us power that one person can manage everything without domain knowledge of specific aspects like how this matrices works or how to build code in Jenkins. Okay, as we mentioned, the subject of tools a few times in this presentation. This is right moment to look closer on it. You can think why I want to talk about tools. Previously, I said that Cloud Native is not about tools. I can agree, but as other things included here, like, for example, work methodologies are easy to be accepted, especially when they give us real benefits. We quickly switch from waterfall to agile, and then changes that make our life easier without much effort are naturally acceptable. Much harder is when we think about tools, and this is the answer to our why. We have tendencies to stack in favorite tools, even somewhere we can find better one. We love what is our preferred tools and don't like to change it and learn new one. As an example, a little bit out of subject, I have a few years ago idea to learn functional programming. Then I decide to choose something that looks close to languages I know. My decision then is to use Elixir, which is very similar to Ruby. Unfortunately, my habits from object-oriented programming imply that things I do there were not fully functional. Lastly, I understand that main problem is similarity between these languages. Then I made next choice and start with Clojure. Clojure is language that for me is similar to everything, and it gave me possibility to learn whole functional approach, but it also grows my object-oriented skills, which is interesting. Here we have same situation. Choosing right tools is most important task. We must get past traps, well-known technologies that sabotage our modernization. This problem is exactly main topic of today's presentation, and we will look closer on these traps. Let's then look what we have on list. We can encounter here three main groups like vendor lock-in, auto migration, or freeze. Also in these groups, we can see some significant sub-subjects that are interested in this perspective. Let's then look closer on each of them individually. The first big problem is in this category is vendor lock-in. It's known not from today that to make a permanent client base or employers, we must make our work that unique that no one can do same job. Then different providers are overcoming themselves, creating tools that should make that just they are needed for us to live. Often this is made a discrete way that we can think that these tools give us free choice, but in the end, just using the provider give us full power of these tools. A great example of that is MongoDB. We can find it in multiple forms, from simple that we can put on our infrastructure or whatever other infrastructure. We have also hosted via Tengen. This is a MongoDB company. We can also find different from different cloud providers. Actually, each have that kind of service. Now, to destroy this beautiful image, I can say that each of these options have different features. Then basic, install it yourself if it's compatible with all. But when you start with one or other, you can have problem later with migration to other provider or to our data center. I don't want to say here about cost of this operation, but it also will be significant. In the subject of vendor locking, this is not only one problem. We can find much more. Let's look some others first. That sounds pretty cute. Is broad availability of services related to the provider. Then this is a little bit connected with previous, but this time we talk about tools that are available only from one provider. And then we can migrate our services, for example, to AWS. In short time, we will get a large number of propositions how we can utilize it better. For example, using XYZ service, we can save 30% of resources. Of course, it sounds very promising, but to the moment when they change, for example, price of other service that is more important for us, at this moment, we can start thinking about migration to another provider. And actually here, problem arrived. Why? Because new provider doesn't have services that we use in previous, or these services works different and offer different set of features. Migration in this situation become expensive and needs much time to happen. For me, the best example of that incompatibility is network layer in particular providers. Considering that this is element of every project. Unfortunately, these elements have different design, then migration can require for us redesigning of our application and even changing tools we use. Google started re-implementing this layer to be similar to what AWS offer, but we've seen that within providers, it's still a long road. We can hear voices that AWS or Azure are new mainframes. When we talk about infrastructure as a platform, important subject is also about stability of our vendors. Last month's Azure problems with DNS show how important role these providers have on our business. Going them to one supplier and thinking that they should care about everything is an enormous mistake we can make. We can lose our fluency, and in edge cases, our client can lose possibility to use our services, even for a long time. As we know, companies are failing or change their directions. Same thing sticks to our providers. And in the end, we can stay alone with big problems. Actually, to avoid these situations, so we should think about it on beginning and prevent from that things. You can think how to do that. Best consider is using hybrid cloud or even multi-cloud solutions that connect few data centers. Doesn't matter our or belong to provider together. In case of problems with one provider, we can minimize our issues or even eliminate them when we are switching or using multiple providers together. This solution is best example for me of idea of abstraction. Like for example, Kubernetes give us. We can use resources from multiple locations and treat it as one platform. This is next big subject, how we can avoid that kind of situations. Getting back to subject of tools, in last years, we have seen a growing trend or new kind of tools that can entirely for free and without our interaction, migrate us into the cloud. no matter public or private. That kind of tools are offered by AWS, Red Hat, and both independent providers that as a service offer us maintenance of what will be migrated. Among of them, we can find a type that migrate our VMs into cloud, but we have also type more intelligent that, for example, will change our DB from hosted to provided service, for example, AWS RDS. Last type that use kind of real intelligence and AI-based can, for example, rebuild our Java code to work with available JBoss that you can get for free for half a year. I've seen also in my career that tricky kind of tools that can migrate you directly into containers. It packs all three services we have, like application, database, and cache, into one container and manage all of it using supervisor. Although we know that idea of containerization is to put one service into one container that we can easily manage it, replace, or scale independent way, then sounds like something bad here. Of course, our bigger problem, even with automatic migration or vendor lock-in, actually is somewhere or another, and is much more fundamental. After full transformation, we can, of course, feel better. Maybe we have more money because for a moment we have smaller costs related to more optimal infrastructure usage. And all of this can hide us fact that in the end we have same software, same patterns, and same technologies. So in the end, we have to stay with our old problems in our maybe better looking environment. When the attraction pass, we can start noticing that our problems are still with us. And maybe we have some savings to quick fix them. For example, by adding additional resources to problematic services. This approach can give us next breath, and for a moment we should be happy, even we can think that we made some success. However, in the end, our problems can come back, maybe with more power, and then we recognize that, for example, decision which database to use is our real problem, not where our machines are placed. In the time when we're talking about this migration and problems, significant motivation we can see here is mostly related with money. Cloud providers promise us big possibilities thanks to scalability, payment for usage, and other like that constructions. From my perspective, this is one of worst motivators to migrate to cloud. Of course, these savings can be used to make broader changes in our system, but be realistic, in the real world, it mostly doesn't happen. Then real motivations for migrations should be a need for better quality, standardization, or even automation. In a long perspective, it will give us more profits, maybe not related with directly infrastructure, but for example, because our IT can work now on new features, not on system maintenance. Last but important trap is migration to cloud and move to new tools, is that using improper solutions can block our works for a long time. Using improper tools can comfortably lead us to hours or even months. We stuck and try to introducing them. But in the end, we can recognize that this is not the tools we need. We must remember that more complex tool is, then harder will be to integrate it into our system, especially if system is not small. Because of that, rather than simplifying and standardizing our system, it can complicate it. Same situations we can find in context of implementing design patterns. I have to work in an organization that won't at all costs introduce event-driven architecture in their system. They start building queue-based solutions, and it gives them only more complications as specification of this business is don't pass to this idea, because structure of operations is more flat. In the end, they rebuild most of their system, but without success. After a few years, they leave this idea and use what they built to make a microservice-based approach. Unfortunately, they lost more than 3 years trying to do it. Finally, they have that technical debt related with lack of time that brought that they leave this software and build it from beginning using another approaches with another team and even in another programming languages. In the time when we talk about logs, it's a good time also to get back to our cleaning and fixing our old problems. Cleaning is a vast subject and unluckily forgotten in process of transformation. Then before starting into choosing new tools, we should start from cleaning what we have. As I said, in one of projects, I removed close to half of the application code. Unfortunately, most often we skip this and goes directly into migration as it sounds more interesting. And we talk in our heads and that cleaning is just next step to do. This approach can block us for a long time when we can try to choose proper tools to things we have. We can spend a long time fixing problems that possibly we can have. What's worse, many tools can help us offering opportunities to work with our ugly problems, ugly solutions, without cutting of what old with a thick line. The most original example I found is AWS mainframe emulator tool that make possible to run code of our old IBM mainframes in the cloud. It doesn't sound for you like asking for problems. Next one, enormous problem. We can stick in migration into cloud native is learning curve. This subject is related to standardization, more standardized and abstract solutions. Then path will be more straightforward and way to share knowledge. Also, people will be more comfortable about touching new problems. For example, when we learn how to configure Kubernetes resources using proper tools, we can use same approach, for example, to manage Jenkins builds or storage matrices using Rook or Ceph. Luckily, many tools offer super UI that can solve our problems in 3 clicks. This way, we leave possibility to manage it one way, best using code in one format. Classically, is the domain of SaaS solutions, but other commercial supporter offers this way, as this is natural business model to solve services for it. Did you consider that learning one technology can be that powerful to control everything in your system? Last and my favorite trap, actually, I want to show today manual steps mentioned on previous slide UI that later we can consider automating using Selenium, for example. I have to hear about that idea, ugly as we know that Selenium is built to test web application in browser behaviors. I love to see origami things like pick cuisine on screen, but as decoration in IT, it should be prohibited under penalty of restriction of liberty. It moves us to inconsistency, creation of hidden knowledge, loss of operation in our platform. When someone, for example, revet configuration to state in the repository, many tools using nicely looked interface, even where web or console, try to manage us to use it. We should treat it carefully, especially this related with specific providers. Did you remember slide from beginning? You can see here that road that we need to overcome to be in our imagined cloud native thinking. However, when we catch these traps, we can go fast to point 4 or even 5, but actually in different direction. And this direction is named cloud enabled. You can think what it is. Cloud enabled, as we can conclude from previous traps, is migration to cloud using improper tools or thinking about bad aspects of this migration. We can discover that we are in cloud, but it gives us nothing, including perspective for future that cloud enabled can close for us. We can then switch between multiple tools, but what they give us, it is a reason why I said on beginning that cloud native is not just about tools, but also about how to use it proper way. We can find tons of tools like AWS mainframe emulator. Then we should be careful and be ready to choosing right. Then let's summarize what are traps we've seen previously that we must care about. First of all, is vendor locking. It's about stacking in some technology without a way out. It's about solutions that are in addition to main technology like cloud, that give us much powers, but mostly with just one vendor. Sometimes these tools are more generous, sometimes less, but in the end, they give you just one choice. And this choice can block us also in context of stability. As you are fully engaged with provider, then their problems start being your problems. Second group is auto migration. Then it's about migrating to cloud with hope to fix our problems. Even nature of it is different. It's also about motivations, mostly wrong motivations, as we want to spend less. And in the end, we stay with same problems as, for example, logic of our applications, real problem, not aspects of placing these applications. The last group is freeze. As I like to say, complex tools introduce complex solutions. They have bigger requirements, and in the end, they make our system more complicated than before. These solutions can make us work on a wrong problem for a long time. They introduce additional learning need in our team, and in the end, they make our system less stable and introduce more manual steps because the process is too complicated to automate it. And in final summary, we can lose control over our system. To avoid these problems, some people say to me that this is utopian. I will give you 5 bits of advices. First of all, be generalist. Use independent tools with multiple replacements available. Then use multi-cloud to avoid vendor problems. Of course, fix your problems first and keep everything simple as possible. And one most important, avoid manual steps. This is why we define a real cloud native. seen our success measurements, pillars to consider, including tools choosing. We have seen traps and name it. And armed with this knowledge, we can go further. I hope implementing you today with this in these subjects, you have partial answers and new questions to consider to go into next steps. After this, you can start thinking about how this stick to you. Having patterns and tools, I show you can start some research on how to start. I want to stop at this point. Thank you for attention. As you can see, this is a vast subject, and you can think about it as long journey. Then, because of that, we want to continue our educational path. Thank you, Artur.
Yeah, thank you, Marcin. So, as Marcin said, we just scratched the surface. This is a huge topic, so stay tuned for more cloud-native content and presentations. And if you have more questions you would like to discuss, please contact us. We'll be happy to have this conversation with you. All right, thank you very much for your time. See you soon. Thanks, bye.